Welcome back to math. Today we're going to try to work with fractions, whole numbers. We call these mixed numbers and fractions on a number line. Lesson 14 is strategies to solve multi-term problems. So let's jump in here. On a subtraction problem, we always start with what? That's right, the total. Nice job, you guys. So I'm going to put my total is 5 7/8. As you notice, I already have my 5 here. And what did I do? I put 8. I cut it into eighths. And so that's going to make my dot right there on 7/8, right?
Yes.
Now I have 5 7/8. I'm going to take a half away. I could do that.
Yes, you can.
I could. But is there something easier to take away?
Yes.
We could take away the 7/8 first. And how we could do that is that we could use what property? Commutative property. And move this over and switch it with the half. Minus 1/2 minus 1.5, right? So I could use commutative property to rewrite my problem. Is it easier for me to take 7/8 away from 5 7/8? You bet. Let's count it together. Ready? 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. So now this guy is gone, right? We have got him all taken care of. The 7/8 is gone. I'm at a whole number, aren't I?
Yes.
Is it easier to take a half away?
Yes.
You bet. So we could make our dot to go where? I cut this up into, I think, eighths here again. 1, 2, 3, 4, 5, 6, 7, 8. I did. What do you think half would be for an eighth? Half of 8b. 4, right. So I'm going to want to count over 4/8, right?
Yes.
Okay, you going to count with me? Let's go. 1/8, 2/8, 3/8, 4/8. So we're now at what? 4.5. So now this half is gone. Is that correct? So now we need to do what?
Take away the 1.
We need to take 1.5
away.
Which one of those do you want to take away first?
Half.
I would take the half away first. So if I'm going to take the half away, that's going to push my dot where?
To the 4.
To the 4
It's going
holes.
to be 4 holes. 4 holes. Yeah.
So this is minus 1/2, right?
Yes.
So now my dot is on 4, and that's gone. So then what do I have left?
Take away the 1.
Take away the 1 hole, and that's going to leave me with, what's my answer? 3. You are right. That is so easy, isn't it?
Yes.
When you draw out a number lines are really easy. It's just you need to get used to working with them, okay? Okay, so let's say we have 7/8 plus a half minus, 3/2. What do we call this? This is an improper fraction. And then we're going to add 2/9. You want to move things around to help us make it easier for us. Is there something we want to put together first?
7/9.
So let's rewrite our problem and put our 7/9 together with our 2/9, because both of these are addition, right?
Yes.
I like it. And then we'll leave our halves together. Is that correct?
Yes.
We'll add a half, and then we're going to subtract 3 halves. Let's make this a 0. We want to cut our line into how many pieces?
9.
Ninths, sure. So just count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 1 whole. Is that right?
Yes.
Okay. So we'll start by putting our dot on 7/9, right?
Yes.
So here's 1, 2, 3, 4, 5, 6, 7. We're going to want to put it here, right?
Yes.
Okay. So that takes care of this guy.
Yep.
Now we're going to add how many? 2 ninths. Okay. So I will just go ahead and add 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's 2 holes, right? So now I'm going to go, how many?
2.
Oh, 2. Wow. 1 ninth, 2 ninths. So now my red dot is on 1 hole. Is that correct?
Yes.
So I've gotten this all taken care of. Now I'm going to add, wow. I guess we didn't have to write out our ninths, did we? But at least we were ready in case we had to. What do I need to cut this one up into? Ooh, halves. So I'll cut this in half. And you know what? I'm going to cut this in half. And then I'm going to put my 3 over here. Okay? Now I have to add what? 1 half. So that brings my dot to here, correct?
Yes.
That's great. I love it. There's only one problem. Now what do we do? Well, we could make our half here and just put it there for the sake of using our halves, right? But how many halves do I have to take away now?
3.
Whoa! I got to take away 3. So, here we go. Are you ready?
Yes.
1 half, 2 halves, 3 halves. So my answer ends up being 0. That is so weird, isn't it?
It's amazing.
That is amazing. Okay, let's look at this problem. 2 and 5/6 minus 1/3 plus 1/6. How could we use commutative property to change this around to make it easier? Well, we could start with 2 and 5/6 and then move this guy next to it, plus 1/6, because notice the plus sign right here. And then we're going to subtract our 1/3. Now we could do that on a number line easily. We have a 2 and 5/6 and then a 1/6. So we're going to be adding these 6 together. So let's just say, let's start with 3 over here. And then we'll have our 2. We'll have our 2 down here somewhere. So how do we do it? Well, we're going to put so many lines here, right? 1, 2, 3, 4, 5, 6. So that's 2, right? Okay. So we have 2 and 5/6, 2 and 1/6, 2/6, 3/6, 4/6, 5/6. So our dot would go there, right? Now we're going to add one more 6th. Where would we go? Well, that's going to be added here, 1/6. Now our dot is on the 3, right? Our dot's on the 3 because we added the 1/6. Now, this part is all gone. And all we have is subtract the 1/3 because this is all gone as well. Our dot's already on that spot, right? So now we're going to take off 1/3. Now how do we make thirds? Well, that's not too hard. Luckily, these are in sixths, right? So if I was going to make thirds, I'm going to do it in, I would say that this is 1/3, 2/3, 3/3, right? So there's our thirds. And my dot is here. Now I'm going to go down 1/3. So it's going to go to here. And now my dot is right there. So what's my answer? My answer is 2. Because my dot is not to the 3. It's in between the 2 and the 3. And how many thirds? 1/3, 2/3. So my answer is 2 and 2/3. See how that worked on a number line? Pretty easy, huh? I didn't even have to fill it all out. I love that. Now your book might have a problem that looks similar to this. The question is 14/3, that's a what? An improper fraction, plus something, we'll call it mystery number, plus 9/4 equals 8 and 11 twelfths. Wow. So, what do? Well, we need to rearrange this. We need to use commutative property. How do we do this mathematically? Well, we could times the two bottom numbers, and we're going to end up with 12, one on each side, right? Then we're going to do 3 times 9, and then we're doing 4 times 14. Well, that's kind of a big number, isn't it? So 4 times 4 is 16. Carry the 1. 4 times 1 is 4 plus 1 would be 5. 56. This is an improper fraction. How many 12s are in 56? How many 12s are in 56? 4 times 12, I would have 48. 5 times 12, I would have, we could do 48, right? So that means that we have 4 wholes, and how many left over? Well, we'd say 48, 49, 50. So 6 plus 2 is 8 twelfths. How many 12s do we have in 27? Well, we would have 2. That's 24, right? So we can convert this over to 2 wholes. And how many left over? 3 twelfths. Then we could add these two guys together. And that's going to make 6. And 8 plus 3, 11 twelfths. So now we have 6 and 11 twelfths, but we need to have 8 and 11 twelfths. What do you think our mystery number is? That's right. Good job. You said let's add 2 to this. Good job. So our 11 twelfths plus nothing below is 11 twelfths. And then 6 plus 2 is 8. So our mystery number is 2. Good job. Okay, we have 6 3/4 plus 3/5 minus some mystery number, and we're going to end up with 5. Could we do this one first? Sure. Let's move our 3/4 down here, plus 3/5. That's going to make our bottom number what? Yes, that's right, 20. 20 here, 20 on this side. And this is going to be 12, and this is going to be 15. If we had 12 and 15 together, we're going to get what? 7 over 20, right? And our 6. Now that we have that, how many 20s are in 27? Well, we have 1 20. How much would be left over? It would be like taking this and getting rid of it, because we took out 120, right? So that leaves us with 7 20ths. And we add those together, and it gives us 7 and 7 20ths. But we need to end up with what? 5. So we have 7 and 7 20ths, and we're going to have to subtract something from that to end up with 5. Do you have any idea what you need to get rid of? Yes, we got to get rid of the 7 20ths, right? So let's put that over here. So that would get rid of that guy. How do we turn the 7 into a 5? That's right, take away 2. So if we take away 2 and 7 20ths, it will give us 5. So what's our mystery number up there? 2 and 7 20ths. That would be our answer to our mystery number. This is lesson 14. I love math.